Alright, I'm just going to do a bunch of examples for you guys, solving by factor. Okay? I'm going to try and give you some hints along the way. Here's our first one. We're going to solve this quadratic equation by factoring. 4x squared minus 24x equals 0. Here's my first little tip. When I see only two terms, 4x squared minus 24x, when I only see two terms, most of the time I'm going to try to factor it by using the greatest common factor. Very similar to the one I just did with the football, kicking the football. Okay? So when I see this, I see there's only two terms, so I'm going to try to factor this by just taking out the greatest common factor.
Which is 4.
So I think in my head, what are both of these terms divisible by, or what do they both have in common? 4 and x. 4x. 4x can go into this, 4x can go into this. So 4x is my greatest common factor. I bring 4x out to the front of my parentheses. What would be left in the parentheses so that if I did distribute it back together, I haven't changed the problem? X minus 6.
So when you do that, how do you get rid of the 2?
Yeah, where's the 2?
It's the x.
Squared.
No, like the 2 squared.
So
X.
essentially I took 4x squared and I divided it by 4x, right? So really I have 4 times x and I divided it by 4x. So the 4's are gone, the x is gone, and you just got that x left over. If I multiply this back together, what do I get? What's 4x times x?
4x squared.
4x squared. What's 4x times negative 6? Negative 20. I haven't changed the problem, I've just factored, right?
Yeah.
It's still the same exact equation, except now it says something times something equals 0. That's a good thing, because now I can solve. Here, I'm guessing you probably can't rattle off your answers real fast. Some of you are good at mental math. You might have been able to come up with both answers by looking at the original problem. Okay? But now that we're right here, I know some of you probably know the answers. I'm going to show my work the rest of the way out. Okay? But I know now some of you probably know the answers because it's something times something equals 0. So either this first something has to equal 0, or that second something has to equal 0. Right? Something times something is equal to 0. So either this something has to equal 0, or this something has to equal 0. So I set both factors equal to 0, and now I can solve because they're both really simple. Divide by 4, and I just get x equals 0. Add 6 to both sides, and I get x equals 6. There are my two solutions. There are my two
Go back to the
x-intercepts.
last step to say exactly what you did because I couldn't see what you were doing.
So to go from here to here, I just set each factor equal to 0. I have, so 4x is a factor, x minus 6 is a factor. This factor times this factor equals 0. Well, the only way that two things multiply together to make 0 is if the first factor equals 0, or the next factor equals 0. So I set them both equal to 0 because I don't know which one
I
is.
did that. I did that part. And then how you get the answers is you basically do what we did in algebra. You just divide 4 to get the x alone, and then add 6 to get the x alone, and then whatever that is.
Solving for x.
Okay, that's what I was confused by.
Okay. So any questions on this one? When I see two terms, most of the time I'm going to solve it by pulling out the greatest common factor.
If you have like 2 terms, but it's just like x squared and then negative 24x, can you factor it just with the x squared, or do you have to do something different? Like if you have 2 terms and one is x squared and the other one is just like a regular number with an x.
Oh, could your greatest common factor just be x? Absolutely, yes. And what I think she just asked there is, what if I add x squared minus 18x equals 0?
Well, it's 1x squared, so you
x is my greatest common factor, and then what would be left in the parentheses?
X minus.
X minus 18, and then,
So you could still do it.
absolutely. Yep. So now my answers are 0 and positive 18. Okay?
What if it was like 3 and 10? Like if it wasn't.
What if there was not a greatest common factor? So are you saying like
3x squared.
plus 10x equals 0 like that?
Yeah.
There's still a greatest common factor.
It's X.
It's x. Both terms are divisible by x.
So no matter what, there's always gonna be yeah.
So then I'd have 3x plus 10.
Yeah. So there's always.
So I'd set this equal to 0, x equals 0, and then I'd set that equal to 0. And when I solve that, I just get like negative 10 thirds, because I have to subtract 10 and then divide by 3. So, yeah, it's not a nice, pretty answer, but it still works. Right? Good, good question. Alright, this guy's a little different. Now there are 3 terms. Okay? Now there are 3 terms. When there are 3 terms, I still want to know if there's a greatest common factor. In this case, there is not. There is not anything that all 3 terms have in common other than the number 1, but there's no reason to bring out a number 1 because you're not changing anything, right? When there are 3 terms, for you to try and factor it, I want you to break it down into 2 sets of parentheses. And in each one of those parentheses will be a binomial, or 2 terms. You guys probably have heard you've probably done the distributing process that maybe you called foiling. Okay? And maybe not. Depends on how your teacher has taught it in the past. Here's how I factor 3 terms. I think what times what gives me x squared. X times x, right? And then I'm going to put a number in each one of the parentheses as well.
5 and 4.
Those 2 numbers, if there is not a coefficient in front of the x squared, or in other words, if the coefficient in front of the x squared is just a number 1, here's what will always work. Figure out what 2 numbers multiply to 4, but add to 5.
2 times 2 multiplies.
Can you say that again?
Okay, 2 times
4
2
times
multiplies
4
to,
and 1.
what multiplies to 4, but adds to 5.
4 and 1.
Positive 4 and a positive 1.
Yeah.
Okay? So in one of the parentheses I'll put a positive 4, and the other one I'll put a positive 1. Doesn't matter which order you do it, because this is multiplication, right? Something times something equals 0. Doesn't matter if I put the x plus 1 first and the x plus 4 second, it's still multiplication, doesn't matter the order. It's called the commutative property. A times b, b times a, you'll get the same thing.
That makes sense.
Now, I do want you guys to make sure you factored correctly, because if you don't factor correctly, then obviously you're going to get the wrong answers. To make sure that you factored correctly, let's multiply these 2 things back together and make sure I haven't changed the problem. Okay? How do you multiply binomials? Well, you take x times x, which is x squared, x times 1, which is 1x, then 4 times x, which is 4x, and then 4 times 4, which is 4.
How'd you get the 4? But that's. Wouldn't that just be 4?
What?
You said 4.
It is 4.
The last one's 4, the first one's X, because you.
Okay, just keep going.
I took x times x, then I took x times 1, then I took 4 times x, and then I took 4 times 4. Skip 4 times 1, I'm saying the answer. I did it twice, didn't I? 4 times 1, sorry. Sorry. X times 1, 4 times x, 4 times 1. My bad. Look at what I got.
combine like terms.
Is that the same thing as what I started with?
Yes.
Yeah, you just
Yes.
said combine like terms.
I just haven't combined my like terms. If I did combine my like terms, it's exactly the same as what I started with. So, that means I factored correctly. That means I factored correctly. So, now I'm ready to finish the problem. What am I going to do with each factor?
Add
Equal
like
to
zero.
zero. Make them equal zero.
When you
Make
add
them
like
equal to zero.
When you're
Up there, yes, but it equals the
couldn't
same
you add
thing.
5x, so it could be x2 plus 5x plus 4?
That's what it is.
That's how we started, x squared plus 5x plus 4.
Yeah, but I'm saying that equation that we just made,
Yeah, you
That was
add-
just,
that could be the exact same thing.
That's what it's
It should
supposed
be.
to.
Yeah.
You're
He was
supposed to
here
add
just
1x
making
to
sure
4x,
it was
so
still
you
the
get
same
5x.
equation.
I'm just making sure I factored correctly by doing that multiplication back together. Carrie, I just multiplied the two factors back together to make sure I haven't screwed anything up. Okay? That's not part of me finishing the problem, that's just me checking to make sure I haven't screwed up so far. Okay? Now, what do I do with each factor?
You find what equals x.
Set them equal to
Zero.
0, right? Because if this something times that something equals 0, then either this first something has to equal 0, or the second something has to equal 0. Subtract 4, subtract 4. Subtract 1, subtract 1. There are my two answers. I'm subtracting 4 from both sides of the equal sign. I'm getting x by itself. I'm not showing my work there. Okay? I'm subtracting 1 from both sides of the equal sign, and I get x equals -1. Graphically, this would be where the parabola does what? Graphically, this would be where the parabola does what?
X
Crosses the x-axis. Those are your x-intercepts. Okay?